Hello student, I'm Madam Noliza. Welcome to Chem Fullmark A session. I was assigned to discuss with you question 1 and question 2 from batch 2015-2016. Here we go. Okay, question 1. A bomb calorimeter contains 780 grams of water, 2.34 gram benzoic acid, burn in the calorimeter, and temperature increase from 25.6 until 37.7 degrees Celsius. So we will calculate the energy released in kilojoule and given heat capacity of empty calorimeter 870 joule per Celsius, and later we will calculate heat evolved per mole benzoic acid. Right, so we are given mass of water 780 gram, mass of benzoic acid, temperature from 25.6 until 36.7. Alright, so how to answer this question? So there are two bodies in this combustion, so we must consider heat release by the combustion, and the other one, that means equals to heat absorbed by calorimeter but mentioned in the question, plus heat absorbed by water. So there are two components that absorb heat, calorimeter and water. So we write in form of Q release equal to Q calorimeter plus Q water. Okay, so Q calorimeter is C delta T plus M small c delta T. So C, the big C, is the heat capacity of calorimeter, and the small c is the specific heat capacity of water. So you just substitute the value, and later you will find the answer Q as negative joule, in joule first, and then you convert to negative kilojoule. Okay, next. So now we already have the value of Q release. Next, we calculate the number of mole of benzoic acid given. So mole of benzoic acid, you take the mass 2.34 gram over molar mass of benzoic acid. You can calculate on your own. So molar mass I give here 122 gram per mole. So we cancel the gram. So now you have mole of benzoic acid 0.01918 mole. And then we make a relationship between the number of mole of benzoic acid and the heat release. Let's say Q is negative Y kilojoule. So we make a relationship here, 0.01981 mole equivalent negative Y kg. So for 1 mole benzoic acid, so you calculate on your own, and you will get negative, let's say negative X kg. And the question asks you to give your answer in enthalpy of combustion. So enthalpy combustion is negative X kJ per mole. Okay, next we move to question 1b. So let's read the question first. Consider the cell notation below for a galvanic cell at standard condition. So we have zinc solid and then slash zinc 2 plus aqueous 0.1 molar double slash. I know you know this one. Double slash means the salt bridge. Okay. And then after the salt bridge, we continue with Fe 2 plus aqueous 0.5 molar. And then iron, Fe solid. So B1, right half reaction that occur at both electrodes. And later we will calculate E cell for the electrochemical system. And the important information here, E naught for iron negative 0.44 volt and E naught zinc negative 0.76 volt. So from this information, we must decide first, which one is cathode and which one is anode. So both value is negative. Both value are negative. So you find out the most negative. More negative, 0, negative 0.76, more negative than negative 0.44. So the zinc electrode will become as anode. More negative is anode and less negative become cathode. Okay, so after that, we will write for B1, we write equation at anode and cathode. So, anode, we have zinc solid in oxidation form, change to zinc 2 plus aqueous plus 2 electron, and cathode, we start from Fe 2 plus aqueous plus 2 electrons, Fe solid. So this is how to write half reaction at both electrode, anode and cathode. Okay, and after that, we find out overall equation. So before we sum up equation at anode and cathode, make sure the number of electron in anode and cathode are the same. If they are not same, you must time with some value. Okay, so they both have 2 electrons, so we can cancel them. Therefore, the overall equation will be zinc solid plus Fe2 plus aqueous. So we have on the right zinc 2 plus aqueous and Fe solid. Okay, class. Next, we want to calculate the E cell. So, B2, before we calculate E cell, we must calculate E naught cell first. So, E naught cell is E naught cathode minus E naught anode. So just fill in the value. E naught cathode is negative 0.44. Negative 0.44 minus E naught N naught negative 0.76. So you can total up this one. You will have positive 0.32 volt. So this is E naught cell. Question asks E cell. So for E cell, we use Nernst equation. Nernst equation. Okay, can you write Nernst equation? So Nernst equation is E cell equal to E naught cell minus 0.0592 over N. N is the mole of electron, log concentration of product. Look at, you can refer to the overall equation. So our product, look at on the right. So we have zinc 2 plus aqueous and iron solid. So we just consider aqueous, ion in aqueous. We cannot take solid. Don't take solid. So fill in zinc 2 plus over reactant. Okay, now reactant. We consider Fe 2 plus aqueous only. Solid, don't take. Okay, so over Fe 2 plus. Concentration. Okay, now fill in the E naught cell. You just calculate positive 0.32 minus 0.0592 over N. N is the number of mole of electron. 2 mole at anode, 2 mole at anode, 2 mole at cathode. So the total mole is 2 mole. So 2 mole here times log concentration of zinc 2 plus. Look at in the cell notation, 0.1 over concentration Fe2 plus. You can get it from the cell notation, 0.5. And you can calculate. So you will get answer in positive watt volt. Okay, class, we have finished discussing question 1 from chapter 8, question 2 from chapter 10. Both are physical chemistry. Now we are going to enter question number 2, the organic chemistry. Right, so we have 2-methylbutane react with bromine in presence of UV light to give monobrominated. That means one bromine, monobrominated product. Okay, now draw the structure of the major product form, and then we name the type of reaction, and later we will write the reaction mechanism. So we will write major product, we name the type of reaction, and write the reaction mechanism. Okay, so let's start. 2-methylbutane. Do you know how the structure of 2-methylbutane? So 2-methylbutane, CH3, CH2, CH, 2-methylbutane, CH3, CH, CH3. Okay, so this is the structure of 2-methylbutane. And this 2-methylbutane undergo react with bromine in the presence of UV. So now you have to give the major product. So the major product comes from more stable free radical. So it comes from this one, this carbon. We will replace one hydrogen from this carbon with bromine. Yeah, we replace one hydrogen from this carbon with bromine. Okay, so what is the product? We have CH3, CH2, CH3, CH3, and the hydrogen we replace with bromine. Okay, so this is the major product for the reaction. Okay, so this is question number 1. Next, question number 2, type of reaction. So this one you can answer very easy question. So this is free radical substitution reaction. And the last part 3, give the reaction mechanism. Okay, so free radical substitution reaction has 3 steps. Step 1, we call it the initiation step. So what do we have in this step? We write down the molecule of bromine, and then we must show the presence of UV light. So the bond in bromine molecule will break symmetrically. That means each bromine takes 1 electron. Okay, so another electron go to the left bromine. Jadi we have Br free radical and Br free radical. So this is what happened in initiation step. Okay, next, step 2. We call it as the propagation step. So what do we have in propagation step? So we take 2-methyl butane, CH3, CH2, CH3, CH2, and we show the bond between carbon and hydrogen that we are going to replace. So this is 2-methyl butane plus the free radical of bromine. Okay, free radical of bromine. So the bond between carbon and hydrogen will break symmetrically. So hydrogen takes 1 electron. Okay, 1 electron give to carbon. Okay, and bromine will form bond with hydrogen. So you will have CH3, CH2, CH3 below, and 1 electron given to the carbon plus HBr. So hydrogen and bromine will form a bond. That is the first step in propagation. And then we take the free radical of carbon. We take this molecule. So CH3, CH2, CH3 radical carbon plus the molecule of bromine. Okay. So bromine will break symmetrically. Each bromine takes 1 electron, and the bromine will combine with free radical of carbon. So you will have CH3, CH2, C, CH3, CH3. So carbon will form bond with bromine, and bromine molecule will give you bromine free radical. So this is 2 steps in propagation. Okay, the final step, step 3, we call it as the termination step. Alright, so for termination step, we just write the reaction between free radical. The first one between bromine free radical and bromine free radical. So what do we have? So they will form bond. And we will have molecule of bromine. Okay, next we take the free radical of carbon. Plus the bromine free radical. So they will form bond. So the product will be CH3, CH2, CH3, CH3. So carbon and bromine will form bond. Okay. And the last one, between carbon free radical, CH3, CH2C, CH3, CH3, and carbon free radical, CH3 here, CH2, CH3. So this carbon will join together and give you CH3, CH2, CH3, CH3. Another bond form here between carbon, CH3, CH3, CH2, CH3. So this is termination step for free radical substitution mechanism. Okay, next we move to question 2b. So we have a reaction of 2-ethyl 1-pentene with several reagents shown below. So this is A, 2-ethyl 1-pentene. So when A react with hydrogen by using palladium as catalyst, you have B. When A react with HBr, you have C. A with bromine and water, you have D. And then bromine, A react with bromine in dichloromethane, you have E. So draw the structure of B, C, D, and E. So the structure of B. Number 1, structure of B. So you will have CH3, CH, because we add hydrogen to the double bond. So CH2, CH3, CH2, CH2, CH3. So no more double bond here. Earlier we have double bond here. So when we add hydrogen, so we will have CH3, CH. Yeah, CH3, CH. So this is structure of B. And then what do we have? If A react with HBr. So for this reaction, you must consider the Markovnikov rule. So hydrogen from HBr will go to this carbon. Yeah, because this carbon has 2 hydrogen atom, carbon double bond. Okay, so this carbon has 2 hydrogen atom. So hydrogen from HBr will come here, and bromine from HBr will come to this carbon. Jadi we write down the product. So C is CH3, and then we have CBr, and then CH2, CH3, CH2, CH2, CH3. So look at the carbon double bond earlier. CH2 changed to CH3 and C changed to CBr. No more double bond. Alright, next, A react with bromine water. So in this case, bromine is react like hydrogen plus. So bromine will come to CH2, and OH from water will come to carbon here. Jadi the product will be D CH2Br. Br will come here. And then COH. And then up here CH2, CH3. Below here CH2, CH2, CH3. Therefore, look at here. Earlier we have carbon double bond here. So CH2, we add bromine here, and then C we add OH. Right, the last one, A with bromine in dichloromethane. So this is, dichloromethane is the inert solvent. So bromine will come to CH2 and another bromine will come to this carbon. So CH2 we add bromine, C also we add bromine. Therefore, the answer for E, CH2, Br, and CBr. So CH2, CH3, CH2, CH2, CH3. Okay, then number two, suggest an alkyl halide and suitable reaction condition to produce A. So suggest alkyl halide and suitable reaction condition to produce A. So actually for number 2, we have more than one answer. So I will give you one only or two only, and then you choose only one, right? So the first alkyl halide that can turn to A is CH2Br, and then CH, CH3, CH2, CH2, CH3, or CH3, CBr, CH2, CH3, CH2, CH2, CH3. So you choose one only. Choose one only. Okay, next, number 3. Number 3. Reaction of A with cold dilute. Look at the question. Reaction of A with cold dilute alkaline KMnO4. Very important, this one. Cold dilute alkaline KMnO4 can be used as confirmatory test for alkene. Okay, the question is, name this test, state observation, and draw the structure of product. Okay, number 3. Alright, before that, I forgot. For question number 2 here, the question asks reaction condition to produce A. So number 2, we can use reagent. We can use KOH in ethanol, and the condition we use reflux. Sorry, I forgot to answer just now. Okay, and then we come back to number 3. So cold dilute alkaline KMnO4. So name the test. So the test is Bayer's test. Bayer's test. Okay, now from compound A react with cold dilute KMnO4. So what is the product? So the product will be CH2. Look at the double bond. We have CH2, so we add OH. Look at the carbon-carbon double bond, and another carbon also we add OH. Okay, so continue, complete the structure. CH2, CH2, CH3. So this is the product when A react with base reagent. And then the question asks about observation. So when we use cold alkaline KMnO4, we will have, you write the observation, the purple color of KMnO4 is decolorized, and brown precipitate form. Okay, that's all for question 1 and question 2. I hope you can answer the question in your coming PSPM final. Okay, class, thank you very much.